Okay, today's lesson is on diamond problems. Before we start our lesson, I'm only going to use a pencil today. If you want to have some different colored pens, that'd be possibly a good idea. And I also want you to remember, as we're going through this, just to listen to the instruction, listen to my voice and what I'm talking about before you start writing it down. So if you wanted to pause your computer and write all this down beforehand, you could do that. Or if you just want to listen to me and then write whatever you feel is essential down, all of these, you could do that as well. So it says diamond problems. Look at each diamond independently and answer questions 1 and 2. Hint, think about addition, subtraction, multiplication, and division. Hints are always a good thing. So question 1, what do you notice about the numbers in the diamonds below? And it said we're going to look at them independently. So we've got 4 different diamonds down here. So we're going to look, it's 4 different problems. And then it said, did you figure out a pattern? Does it work every time? So let's take a look at this diamond. And we have 4 and 2 and 8 and 6. Well, I think I know what I want. But I'm going to hold off a second. I have 2 and 5 and then 10 and 7. Okay. 5 and 4 and 20 and 9. Yep. And 11 and 3, which is 33 and 14. Yes, I have figured out the pattern. What I want you to do right now is pause your computer and take a second and try to figure out if there's a pattern between these 4 numbers, and then see if that pattern, or see what they have in common, see if it works over on this one. And then see if it works over on this one, and see if it works over on this one. Okay, now that you are back, if you figured it out, let's see. If you haven't figured it out, I'm going to ask you a question. What do these 2 numbers have to do with the top number? How could these 2 interact to get the top number? So 4 times 2 is 8. So 8, we could call that the product, because that's the answer to a multiplication problem. And then 4 and 2, how do they interact to get 6? Well, 4 plus 2 is 6. So the 6 down here would be the sum. Now let's see if that works here. 2 times 5 is 10. So again, 10 is our product. 2 plus 5 is 7. Let's try it again. 5 times 4 is 20. 5 plus 4 is 9. 11 times 3 is 33. 11 plus 3 is 14. So I think that's our pattern. Now let's check, and I'm going to add some different ones in here and try another batch. It says, now determine if your pattern works with these diamonds. What pattern did you figure out? Does it work every time? Well, we already kind of figured out the pattern. Now we're going to check it. So in this situation, what's different between the first set of 4 and the second set of 4 is that we've got a negative number here. So 8 times a negative 1 would be negative 8, because a positive times a negative is a negative. 8 minus 1 is 7, so it does work. Negative 3 times 5, negative 15. Negative 3 plus 5 would be positive 2. Negative 10 times 2, negative 20. Negative 10 plus 2 would be negative 8. Yeah, that works. Negative 6 times 5 would be negative 30. And negative 6 plus 5 would be negative 1. That works. So our pattern again is the top number is the product. The 2 side numbers, they are either the factors when we're talking about multiplying, or the add-ins when adding together. And then the bottom number is the sum. Okay? And the last one that I'm going to do is I'm going to have you try and figure out. In this case, I'm going to have you figure out, and this is how you're always going to see the diamond problems as we do them. You're going to be given 2 out of the 4 pieces, and you're going to have to figure out the other 2. So why don't you pause your computer, and then we'll see what you get. So in the first one, 4 times 2 is 8. 4 plus 2 is 6. I think we just had that one. In the second one, it gives us a product of 15 and a sum of 8. Well, when we're trying to find the two factors, what I like to do is list all of the factors of 15. Since this is a positive number, you're going to have two positive numbers. So 1 times 15. Does 2 go into 15 evenly? No, it doesn't, but 3 does. 3 times 15. Does 4 go into 15 evenly? No, but 5 does. 3 times 5 here, 3 times 5, and then 5 times 3. And you'll know you're done when your numbers repeat themselves. 5 times 3 is the same as 3 times 5. So here are factors of 15. Now, which of these add up to 8? Well, it would be 3 and 5. So we would put 3 and 5 there. You could also put a 5 on the left and a 3 on the right. That doesn't matter. So the factors can go on the left side or the right side. On this one, we have a negative number up top, which means we have to have one positive and one negative number. We're going to list our factors down here. And that would be, and since the 10 here is positive, we're going to know that the bigger number, when we're adding a positive and a negative, needs to be positive. So our 24 times a negative 1. Does 2 go into a negative 2? Negative 2 goes into 24 12 times. Does 3? Yes, negative 3 goes into it 8 times. Does 4? Yes, negative 4 goes into it 6 times. Does 5? No. Does 6? Yes, 6 times a negative 4. And again, remember how we talked about as soon as our numbers start repeating, we are done with all of our factors. And now we just have to figure out which one of these, when added together, equal 10. Well, 24 plus a negative 1 would be 23. That's not it. 12 plus a negative 2 is 10. That's our answer. So 12 and a negative 2. 8 and a negative 3 would be 5. That's not it. 6 and a negative 4 would be 2. That's not it. Okay, and we'll go to the last one. Again, they're given our factors and our add-ins, so we just need to multiply and add. So 6 times a negative 4 is negative 24 up top. 6 plus a negative 4 would be 2 in the bottom. And that's how you do diamond problems. And we will be doing many of these. They're a great little warm-up activity. And you see these a lot in Integrated Math 2, your sophomore level math class, when you're simplifying quadratics. Have a great day, and I hope you understand this. Now, why don't you go back and watch it again and get some practice in.